Hello, everyone. Hello, those of you just joining us again for the last day of Installer Fest. Let's give it another few seconds or so as everyone logs on to see us here. It's great to see so many of you back again. Attendees already kind of climbing up. I will just give it another minute so we don't have to do the intro twice, but just make sure you can hopefully see the screen, so make sure your audio's working. And we'll kick off in a minute. Let me just say thank you again for joining. We're here on the last day of the Installer Fest. It's been wonderful to have so many of you join us so many times for all these different talks and presentations. And we are very excited that Christian has come back again. So we had the first session on Monday from Viessmann, who is the technical director there, and he's today going to introduce the Vitocal 100A monobloc air source heat pump, and we're going to have a good presentation on that, so we're going to learn lots more about it. He'll also be available to take questions on all things heat pump related, and talk about the industry a bit more broadly. So if you've got those questions, do post them in the Q&A function, and we will do our best to answer as many of them as we possibly can on the webinar today. And if not, we can always get that back to you, get that information to you after the show. So it'll be recorded as well, and you'll be able to see it all online. So that's it for me. It's great to see we've got 30 or so people with us, and I will pass it over to Christian to go through a bit of a presentation. Thanks, Christian.
Yeah, good afternoon, everybody. Welcome back. For those who have maybe listened and seen me on Monday, today we were just talking about the Vitocal 100A. It's a new monobloc air source heat pump we are launching next month, and the information will be just predominantly around this new model. But please feel free, have any questions in the chat box as been suggested. Just in case, for those who may not have listened on Monday, we are not covering any sort of installations or any other requirements on air source heat pumps. We have done that one in depth on Monday, but if you're new to this one, feel free to ask any questions surrounding the installation or whatever later on. We are just focusing on the air source heat pump Vitocal 100A right now. So as I said, the heat pump market and everything else, we will skip that. That was a Monday session. Now we're starting at point 5 about the products and what's new about the product, what's special about it, how does it perform, what can you expect from it. Then also, most importantly, I think we were then covering a couple of typical hydraulics schematics examples and wiring examples. You maybe come across this and what you need to consider. And then we are already finished for today, and then we can go to our long deserved bank holiday weekend, at least for those who have Monday off. So as a short overview, air source heat pump, monobloc, single phase power supply, 240 volts. We have, with the new 100A, we have also the Vitocal 200A and the Vitocal 222A model available. The latter two are models which we have been selling for many years. And there are 230 volts, and there's two ranges available. So we have, putting the pointer on, the 200A is a monobloc unit with a indoor unit. The indoor unit houses the controller and circulating pump in 3-port valves and any flow heaters. So it's all neatly tied into a separate housing, which has got the size of a Warlang boiler, literally. And then we have the very popular model with a integrated hot water cylinder, 220 liter, which is a 222A. These are not part of today's discussion. If you want to, we can do that in a later stage. But today we're just focusing on the new Vitocal 100A model monobloc unit, between outputs between 6 kilowatt and 16 kilowatt. So the model is designed obviously for the domestic residential market. It's a single heat generator unit, and it is ideal for new build applications, also for retrofit applications, and apartments and other residential domestic applications, whatever people would like to consider an air source heat pump for. So the range is coming into 3 sizes of the outdoor unit sizes. So we have the smallest one, which is a 6 and 8 kilowatt output model. Then the middle-sized model is a single fan, again, is 10 and 12 kilowatt. And then we have the twin fan unit, larger and taller, where then the output is between 14 and 16 kilowatt. All the heat pumps are now filled with the environmentally friendly R32 refrigerant gas. And here is a short overview definition of our boiler codes. Important, obviously, when people like to order this. So the AWO stands for air, water, outdoor. M is the single phase option, which we only have available for the UK. And also the option for the UK is the antifreeze option, which I explain a bit later. Then the number game is that we have obviously the definition of the product segment, like a Vitocal 100. There's no hot water cylinder included in this. And then we have the first generation A, and the capacity is the last 2 letters. So that's the overview. Some benefits or features of this is obviously the new eco-friendly R32 refrigerant gas. And then we have flow temperatures up to 6 degrees. It is also capable for cooling if people like to use it. I have to tell you that the government is not very keen on using the cooling function, but cooling is available. And then we have a high COP efficiency of up to 4.9. And then the easy installation part is because the unit does not come with an indoor unit. So all the components are actually integrated into the outside unit. Important is from the efficiency point of view, which I come in a minute to this, is obviously we need to understand what temperature operations we are talking about. I've mentioned that one last Monday. So A7 stands for outside temperature 7 degrees, and W is the water temperature, which is the supply temperature to the heating circuit of 35. And the cooling output is defined in outside temperature of 35, water temperature of 18. So just again, just to refresh these definitions there. What are the advantages for the users? Obviously, the new models are space saving. They're fairly compact. It makes the outdoor installation a bit simpler, and also aesthetically, hopefully a bit more pleasant for homeowners. We have obviously the outside units coming in 3 sort of power ratings or sizes of the fan collector box. Then recommended for new build and modernization, so pretty much across the domestic segment. All components are integrated into the outside unit. We have energy saving power regulations for nighttime operations and so on. Also with a modulating DC fan. The installer does not require refrigerant certificate. What it means that because it's a monobloc unit, the unit is pre-filled with the refrigerant, and during the installation, you not need to handle the refrigerant. You don't need to connect any refrigerant pipes to it. It's all pre-fitted and pre-filled by us, and therefore the installation can be done with a normal heating engineer, installer, without having the requirement of an F-gas certificate for handling refrigerant gases. That will only be required if you are deciding to do some servicing work on the machine, or if there's a leak and you need to attend this machine and need to handle the refrigerant gas, then these F-gas tickets are required. That's basically the same as working on a gas boiler. Yeah, easy and quick to install. We will demonstrate that later on the schematics, what you actually need and how nice the machine can be integrated into standard UK homes installations. Environmentally friendly, yeah, because of the refrigerant gas, R32. Then we have also a corrosion-resistant gold-plated evaporator heat exchanger. That design makes the system very suitable for coastal installations. As you can imagine, if you have a coastal installations close to the sea air is contaminated. I wouldn't say contaminated, but it's got salt in the air, and salt is obviously very aggressive when it sits on metal surfaces, etc. So then the materials need to be especially coated to cope with this. And some manufacturers do have a specification of how close the unit has to be fitted to the sea side, and with the corrosion resistant evaporator heat exchanger we're offering, it means that the units can be fitted very close to the seaside. We also have remote control components, accessories available for this, and also we're offering then a 5-year manufacturer's warranty for this, with an option to increase that to a chargeable 7 years. I've just put a copy in here of a typical energy label. If you want to share those information with end users, the new heat pumps are all triple rated efficient at low temperatures, and at the high temperature they still have got an A++ rated efficiency rating. The other information here basically means that which area and climate zone the machine is designed to. Then we have here also the sound power level information, which also gives a good comparison to other machines. The machine, how it's been broken down to, what type of components it contains of. So we have number one, the fan, which is the DC operated modulating fan. Then number two is a large evaporator heat exchanger. Again, I've discussed it earlier this week. There are obviously certain considerations which have to be made in terms of the efficiency and the quietness of the operation of the machine. So we are restricted to the size of the evaporator. Number three is the control board. There needs to, that's where the electrician is connecting all the cables to it. They're coming in from the back. And then on the right hand side, we have the rotary twin compressor located in here, all the refrigerant pipes and water pipes from the condenser. The condenser is here number 5, pre-insulated plate heat exchanger. Then the circulating pump, also included in the machine. So that is the pump which pumps the hot water into your property to feed the radiators and your hot water cylinder. And then we have the control box located on the outside of the machine. And here at the bottom, we have the flow return connections where you then connect your pipes to it, which then been leading into the property. Some technical data you will see from our brochures. So we have the models from 6 kilowatt to 16 kilowatt. The output, as I said, from 6 to 16. The COP value at a temperature of 7 degree outside temperature and 35 degree flow temperature from 4.5 to about 4.7. So very, very efficient machine. Single phase machine, maximum flow temperature of 6 degree, and then sound power level from 64 dBA onwards up to 68. Here are the dimensions of the small units. So the 6 and 8 are the smallest one with a depth of 380 millimeter, 900 millimeter wide and 800 millimeter tall, and a nice cozy lift weight of 72 kilograms. Going to the next size model is 455 millimeter and a meter wide. And then we have got the twin unit here, which is the tallest with about 1.4 meter tall and 125 kilograms heavy. And then all machines have got a triple plus rated energy label. More information about the COP, I've discussed it at length in the other session, but here just give you again just an overview of how the efficiency and the outputs are changing by selecting a different operating mode. So this is just for the 10 kilowatt machine. In here we have the hot water temperature, 35, 45 and 55. And here on the left hand side, this is the air temperature. And these are our test points, so -7, 2 degree, +7 degree, and +12 degree. So you can see that if you use the worst case scenario for a heat pump, running it at 55 degrees at -7, that's obviously the highest temperature you want. The output is 8.3 kilowatt. But if you run the air source heat pump at 12 degree outside temperature and low temperature, then you will see that the output is increasing by more than 20%. And that's the classic behavior you have with every air source heat pump. So please, again, do not size the heat pump for property. It may be at 10 kilowatt for the property. They need to be sized to the minus degree, because that's usually the average outside temperature in the UK, or the coldest winter expected temperatures we need to see. And how efficiencies are different. Again, we discussed it in depth last time, so some of you may have remembered this. But again, the higher the operating temperature is and the colder the outside temperature is, the efficiency of the heat pump will drop significantly, in this case to 2.1 for this model. And then the warmer it gets and the lower the operating temperature, then the efficiency increases significantly to about 5.1. So that's a 300% increase on efficiency. Again, this will then determine the happiness of the homeowner, how the heat pump has been used, etc., and how effective it is, and how much electricity they pay in the end for running it. So these are just information. So the documentation for this model are demonstrating all the different operating conditions and the efficiencies of this. Down here in red is the seasonal efficiency. So you may remember last time I've mentioned that as well. This is a good figure you can then discuss with the homeowner, how the seasonal efficiency then changes. As I said, COP is the measured efficiency from the manufacturer. The SCOP is the seasonal effect. So this assumes the seasonal effects from the winter to autumn and spring and summer operations, and averages the efficiency across the year. So running the heat pump at 35 degrees, the SCOP is 4.5, and running the designing the air source heat pump system at 55 degrees at the coldest day of the year, obviously they're running with weather compensated controls, then the seasonal efficiency will drop down to 3.3. So they're all good values, but again, it's important to consider this, and these values are all available from 35 to 55 degrees on the MCS database for every heat pump model from all manufacturers who are actually listed on the MCS database. So just as a reminder for this one. So for whom is the heat pump? The 100A, as I said before, is ideal for heating engineers and installers who are not F-gas registered, who just wants to or come across inquiries now to fit heat pumps, because obviously the world is talking about heat pumps everywhere. So this model makes it ideal for those people who are not really into F-gas registrations and certification. And then this model will be quite good for that. Small compact machines for the outputs available, and also no indoor unit to consider. So if you have reduced space requirements or space available in properties with terrace houses, for example, or apartments, then that model will be quite attractive for this. And again, the installation can be quite fast and quick, because of most components, or majority of components, are integrated in the outdoor unit. This is just an image here of the machine in the flesh. So it's mounted on some soft mounts as an option. You can mount them on slabs in the garden, put some gravel around it. That's certainly one thing, but we do provide some soft feet to minimize the vibration from the unit. Here are the flow return connections. Before they're going into the property, obviously any exposed pipes needs to be properly insulated. If the unit is further away from the property, then it would be recommended to bury the pipes into the ground and then feed them into the building then. But again, fully insulated pipes. And here we have the controller here on the side, accessible from the outside. A few more images here. Front view of the heat pump. Then this is a rear view. You can see the cable entries here for the power supply and 3-port valves and sensors. And then we have, again, the side view with the controller and the box here for covering the flow return connections. And another few pictures here with the controller being illuminated. The information in our documentation will provide you good access to the basic functionalities there. And as I said, the heat pump will do heating and cooling options if wanted or required. The electrical connections are located on the top of the machines. So again, easily accessible for the electricians and easily labeled. It just needs the power supply to it and the connections to the 3-port valve, which is located inside the property, and the hot water sensor, and all the other cables are obviously fitted already into the machine, is factory fitted. Clearances, again, one of the things needs to be observed. So with the outdoor unit, it is required to maintain some form of minimum clearances. We do see it that customers would like to hide the machine into boxes or wooden sheds building around it. But please make sure, if that's been done, that there are still clearances around it, so installers, service engineers can easily work on these machines. And these are sort of minimum clearances we do recommend. Also to the top, about half a meter to the sides, that should be sufficient to allow people to work on this machine safely. Clearances to the back of the machine, that's where the air comes in, so minimum is around about 400 millimeter. If it's maybe a bit less, not so critical, please just make sure that the air is freely able to enter the back of the machine, because the fan is pulling the air into the machine. Any obstructions there, even window sills obscuring the airflow will make it difficult, and the machine will then not be able to get all the air through the evaporator, and therefore loses performance. And the same is to the front. The air needs to be freely then blown out to the front of it. So we need to provide a decent distance to the front. Also, because if you put plants or bricks next building right in front of the fan unit there, you're creating potential damage to the fabric or to vegetation, because in the winter there is negative temperatures coming out of here, and you're creating some permafrost conditions, and that's not really desirable. But also obviously the fan performance are suffering from it. So these are the minimum requirements. Then here we just have a quick note in here that also any underground shafts or manhole covers need to be sort of avoided within the 5-meter distance of the outdoor unit. This is again the reason for the new refrigerant gas. That is a propane-based type of refrigerant gas, and any leaks could drop into the cavity beneath the machine, and then could cause some hazards there. So that needs to be observed. The refrigerant gas is heavier than air, so it will naturally drop down in any sort of, as I said, voids or manhole covers below the outdoor unit. So that needs to be considered as well. Then what accessories we have available? Obviously the 3-port valve, which I'll show you in the schematic diagram a bit later. That's for switching between hot water mode and space heating mode. We do have an attractive option there for buffer storage, and external buffer storage. That will also can be used as a plinth, so the outdoor unit can actually be mounted on top of the buffer store outside of the property. Ideal for space-saving installations where inside the property there's not enough space for additional buffers or etc. I've discussed last time the requirement for buffers, and when it's required to have buffers in place. So that is certainly an option to minimize any space requirements. Then we have a thermostatic valve. The recommendation from Viessmann is that the water pipes to the outdoor unit and back into the building do not have to be filled with an antifreeze glycol. So because as long as you are covering the pipes appropriately and insulate them, certainly all exposed pipes, then they will be fine. But any glycol in the pipe systems will also have a negative impact on the performance of the heat pump. It reduces the output because of the viscosity of the medium is changing, and then the circulating pump is not able to provide the right flow rates. So therefore we have an option for a thermostatic valve that's required if, for example, the homeowners are like to go on holiday over the winter period and switching all the heating off, which most people do in the winter. In case of potential freezing up of the outside unit and causing damage to the machine because of freezing water is expanding and then creating pipe bursts or any other components bursting inside the machine, this is a thermostatic valve to allow expanding water to be drained into the outside. Well, as I said, it's an excellent optional extra. And then obviously other accessories like an expansion vessel or any other pipe work you may require. And finally, we have an accessory which will be very important for you. This is a combined hot water cylinder and buffer store, all in one unit in this slick design. 250 liter hot water cylinder available, and underneath, separate from the hot water, so it's obviously not linked to each other, but it's a separate design, is a heating buffer store of 50 liter. All in one, so you don't need any extra spaces for the buffer store wherever it's required. And then the storages can also be fitted with some additional immersion heaters where and if required. So that model will be available also together with the heat pump. So here we have some schematics. So this is the first one, and I'll put a picture up here also to simulate that the schematic is more or less sort of similar to what we've drawn up in here. We have the outside unit in here, which is this part here, and then the flow return pipes going into the building and going to a 3-port valve. The 3-port valve is located inside the building and controlled electronically by the heat pump. So one flow pipe goes into the hot water cylinder, which is the top part of this part, and then the other outlet hot water pipe goes to the buffer store. From the buffer store, then there will be a separate hot water circulating pump to your underfloor heating circuit or radiator circuit, and that circulating pump can be controlled by your room controllers, programmable room thermostats, wireless room thermostats, or whatever is available. And then obviously internally you need to then also take care of an expansion vessel, which is obviously depends on the water volume you have in the system and the safety valve. So that's very simple. The wiring side of it, we have here obviously the electrical power supply there with a isolator switch, which is sort of shown here. And then we have the low voltage temperature sensor going back to the outside unit and the 230 volts power supply for the 3-port valve. These are the only really components, electric components you need to wire into the outside unit. The rest is all hopefully maybe electric components and wiring, which is already available because you're replacing an existing systems. So it makes it quite easy and attractive. And as I said, that combi cylinder is ideal for very close space, air and covered installations and whatever people have, utility room or garage, etc. And then this one here, that schematic is probably currently most common used in the UK. Again, outside unit here with pipes going directly into the property. 3-port valve switching between a separate hot water cylinder and then directly into the heating circuit. Last time I've discussed obviously the need for a minimum water volume because of the defrost cycle the air source heat pump will naturally go to. So therefore, if the minimum water content is not achieved, then you do have the options and have to put some provisions in there to increase the minimum water volume with a wall-mounted buffer store. In this case, it's from Viessmann, 45 liter space-saving wall-mounted unit. can be used. You can use maybe some other means as well, but it's important that the water volume in the pipes is considered of at least 50 liter. And I said last time, the water volume in radiators are not to be counted, and only the water volume all the way up to the nearest two-port valve or actuator valves or TRVs fitted in the heating system. Electrically, same here as well. We have a wireless room thermostat, which then controls the two-port valves in the building, the zone valves, and then we only electrically wiring the three-port valve to the heat pump and a sensor for the hot water also directly to the heat pump. And that's all what is needed. So this is more like a typical installation you will see with any gas boilers or oil boiler installations right now. So that's for me. Here is just a legend of the components on the schematics. We do supply a copy of this presentation, so you can read up on this if you have any questions. And then finally, people will naturally ask for this. What will be the price point roughly for the heat pump? I've just put in a copy of our price sheet for this machine. These are list prices, so obviously you do need to check with our sales team or perhaps merchants if you prefer offering buying the machines from the merchants, what the price point is going to be. But this gives you sort of an idea what we're talking about. We do also provide direct sales opportunities to installers. That's also an option if that's what you would like to do. So that's for me. I hope you may have some questions we can discuss right now, but I'm finished now for this point of view. So I'm handing over to Ben.
Great, thanks, Christian. Really helpful, really informative presentation there. Hopefully that gives you lots of information to take away. And yeah, we will share, if you like, the presentation and the video afterwards. But for now, we have a few minutes for anyone, if you have questions for Christian, whether it's about this or about anything else that we could hopefully answer. So feel free to post them in the chat, or we can raise your hand like virtually on the thing, and we can kind of call on people to answer them there. So Robert, you're just asking about the flow return pipe size. Is that one you can pick up there, Christian? Yes.
Flow return pipe sizes. What we usually recommend is it's about 28 millimeter. We discussed that one briefly last Monday. It's again, large pipe sizes do help to provide you with a decent water volume as well. But the pipe sizes naturally is also dependent on how far the outdoor unit is actually located away from the property. So the further it is away, then the larger the pipe sizes needs to be. So if we have 5-10 meters distance to the property, we do recommend pipe sizes to the property of DN32, which is the minimum diameter, needs to be considered to overcome the pressure drop in the pipes. And then within the property, if there's a buffer vessel fitted like I've shown you before, then from the buffer to your heating system, that could be your standard pipe sizes you have. So you can use your microbore systems, you can use any other pipe sizes you have, as I've shown here. I'll go back to this system here. If you have this type of installation, for example, the pipe sizes between the outdoor unit, let's assume the outdoor unit is close to the machine, and the buffer store, we say 28 millimeter, that's fine. From the buffer to your heating system and circulating the water to your radiators or underflow system, that can be of your choice. And then the pump obviously will be calculated accordingly. Okay, great. Thanks very much. Sam Davies is asking about a couple of questions. So which merchants are looking into supplying these units, and do you have a rough guide price of the units yet? Right. Guide price, I mean, I've provided here some list prices here. A guide price, it's subject to if we are selling to the merchants. We have a big range of national merchants where we're supplying our gas boilers to. Naturally, those merchants will then also supply then the unit as well, if that's what you want us to do. The merchants are quite good at that. You just picking up the part numbers from us, and then you go to the merchant and say, I want that machine. The prices the merchants will provide you, I can't tell you this, but these are the list prices there, and there will be probably a discount around, I would say, I'm cautious here right now, but maybe around about 30 to maybe 35%. But again, that is subjective to the merchants, so I can't really comment on those. But obviously there will be a potential for direct sales as well, and then the terms and payment terms will then be discussed with our sales team.
Okay, thanks Christian, and thanks Sam for that question. We'll leave it open for another minute or so in case anyone is frantically typing away or has anything burning that they've forgotten, but perhaps Christian and Darren, I think, who are also on the line, will be able to. There are plenty of questions on Monday as well, which we're hoping to kind of get back to you on as well. Kevin, will you be offering an umbrella scheme similar to the Valiant one for the MCS registration? Yeah,
I mean, Viessmann is already certified as an MCS installer for air source heat pump. We are just internally sorting out our internal processes. So I'm not really keen in using the word umbrella scheme. I like to use it more like that we are supporting the installer with the MCS, because obviously there are government regulations and requirements of the risk we are taking to take on the MCS installations and so on. But yes, no, Viessmann is already certified. It's just watch that space. We're just finalizing our processes, and then before we communicating that to the marketplace and so on. There is a bit of work to do in terms of providing you with a brief. We also want to offer a quick training as well, how we are will work with yourself to do this MCS type of things, and what information are required, and what Viessmann will offer you to support you on that scheme. Yes, it's been very important, but the important steps have been made that Viessmann is an MCS installer for this. So yeah. Great.
Okay, thanks. And then Christopher Jinks is asking about the maximum heat load.
Yeah, the heat output of these machines, as I said, is 16 kilowatt. And then the heat output is obviously, is the heat output required or the heat load? Is the electrical load?
Heat load, I think, is what Christopher is asking.
I would say he probably means the heat output. Okay, so it's a 16 kilowatt model here, and it's 16 kilowatt at a 7-degree outside temperature, and the output will obviously drop gradually a bit the colder the conditions are. So let's say at -1 or -2 degree, the output will be around about 12.6 or 13 kilowatts. So yeah, that needs to be watched for.
Does that answer your question there, Christopher? I might just allow you to come off mute if you'd like to say or to type in.
Yeah, because he has typed in and said heat load after that clarification. So is it possible for you to answer the question from a heat load perspective? In fact, he's clarified a little bit to say he's got a job to do with a total heat load of 65 kilowatts, whether we do anything suitable, Christian.
Yeah, 65 kilowatt is I would say, well, it's either a very large residential stately home or a commercial installations. We do have commercial installations, heat pumps available as well. They are 3-phase, so 400 volts. So the first question is 400 volt available? And to covering 46 kilowatt with a 230 volt heat pump is difficult. Now we can cascade these machines to up to 7, but that means you need 7 individual single phase cables to the unit, and then that needs to be checked with the power supply whether you have got enough. The 100 amps power supply will certainly be stretched to the limit.
I think.
Yeah.
I think 3 phases available. The building's currently heated electrically.
Yeah, so we'll have to look at other options there. That model here is mainly for residential domestic applications. Larger outputs, we will have to come up with a different design for this. Yeah.
That would be the 350G Pro, would it?
Well, no, I mean, we have other models, depends what customer's looking for. Yeah, we can use air source or we use ground source technologies. Yeah.
Okay. Thanks, Christian, and thanks, Chris, for the question. Joanne's asking about, do you have plans for a hybrid gas and heat pump model, or any technology to combine gas existing boilers with a heat pump?
Yes, so these questions are coming up quite nicely, and it is interesting. So the hybrid technology is combining a gas boiler with a heat pump, and there are different models available. One is that the heat pump and gas boiler are combined into one machine, let's say, and sold by a company. We do have that one, but we don't sell it in the UK. Mainly is because the heat pumps are already expensive, and we're trying to make the heat pump as a monobloc unit. But B, in majority of cases, people want to use the existing gas boiler or oil boiler to work with a heat pump technology to jump or to have a gradual move to heat pump technologies. So we do those, not necessarily with that type of model. We have the other models are available, which are perfectly equipped to operate with an existing heat generator on site, and we also have schematics. So there's a bit of a work to do from the schematic side to ensure that the system works effectively. But yes, we can do those. Yes.
Great. I think, Sam, do you have a question? Do you want to come off mute and ask that, or type it in the chat? You raise your hand. I'll give you a second to talk there.
No, I think he's covered everything for me.
Okay, brilliant. Great, guys. Yeah, so please, thanks very much, Christian, for that presentation. Thanks, Viessmann, for coming on here and giving us your time and that knowledge for us to share. Thanks, everyone, for joining this session. And if there's any further questions, don't hesitate to kind of email them in, and Christian, Darren, the team at Viessmann will happily kind of get back to you. So that's probably it for now, but thanks for joining, and have a great weekend, everyone. Brilliant.
Thank you very much.
Christian.
Thank you. Have a good one. Thank you. Bye-bye.
Cheers, everybody.
Bye-bye.